Good morning, good afternoon, good evening, whenever and wherever you are. My name is Anna Rochelle, and today we are going to do the second page of this review that a couple of students sent in. We are looking at a chapter 3 review from chapter 3 from Big Ideas. We're still looking at quadratics. We're still looking at different information of these quadratics. How to graph them is ideally the goal. In this particular case, we're going to talk about on this page the discriminant, substitution in systems of equations, and one-word problem. Okay, let's get right to it. So in order to find the discriminant, our job is to go ahead and look for the thing that's inside of this quadratic equation, inside of the square root, not including the square root. So all we're looking for is b squared minus 4ac. Okay, so our goal is to get this function, or this quadratic equation, into the standard a squared plus ax squared plus bx plus c equals 0 form. This one is already in that form, so I'm just going to label my a is 4, my b is 6, and my c is 9. And then I'm going to replace all of these pieces of information with these three. So I'm going to have 6 squared minus 4 times 4 times 9. So 4 times 9 is 36. 36 times 4 is 120, and 144 minus 36. Well, I guess 36 minus 144. So if we're going to take a look at that, we're looking at, let's just do some quick maths here. That's 3, that's 14, 4, 8, 108, but it's going to be negative. So my discriminant is negative 108. When I look at these numbers of roots and the types of roots, one thing that's going to be very clear. Eventually, I will have to square root this when I'm looking for the actual roots. When I have a negative inside of a square root, that means I'm going to have an imaginary number. If I'm going to have an imaginary number, my roots are going to be imaginary. Imaginary roots always come in groups of 2. So if we take a look in the past, when we did in the first on the first page, we did negative b plus or minus the square root of all of this divided by 2a, right? This plus or minus right here, this is my goal. This is the thing that's going to tell me, hey, you have 2 roots at all times, especially when they're imaginary, because I'm going to have plus I root 108, and I'm going to have minus I root 108 in this particular case. So whenever I have imaginary roots, I always have 2 because of this plus and minus business. Let's take a look at this one. So here, my equation is not in standard form, so I'm going to put it into standard form by subtracting this 1. So now I have my a is a half, my b is 1, and my c is negative 1. So I'm going to have 1 squared minus 4 times a half times negative 1. So 4 times a half is negative 2. Negative 2 times negative 1 is positive 2. 1 squared is 1. So now I have 3. So in this particular case, I'm going to end up with this negative b plus or minus root 3. Root 3 is not really a thing. It's 1 point whatever. So my discriminant is regular 3, because that's what I'm looking for. This is the discriminant here. This is the discriminant here. In this case, it's negative, right? So when I look at this again, because I'm going to add or subtract this root 3, again, I'm going to have 2 roots. In this case, however, I'm not going to have imaginary roots because there's not a negative in the radical. I am going to have real roots. So I'm going to have 2 real roots in this particular case. Let's take a look at this one. This one is all sorts of crazy pants because I have to rewrite the entire function. So I'm going to have negative 5x squared plus 10x, because I'm moving the 10x, and then I'm going to move the 6, so minus 5 equals 0. Now, option number 1 is we can divide everything by 5 and call it a day. I have seen in the past, though, that the teachers and the big ideas, like the homework assignments, don't accept when the discriminant is divided, when you're dividing everything and then doing discriminant. So we're just going to do lots of math today, okay? So we have A is -5, B is 10, and C is also -5. So B squared is 100 minus 4 times the -5 and the other -5. I know that -5 times -5 is 25. 25 times 4 is 100. So I'm going to have 100 minus 100, and that just equals 0. So my discriminant in this case is 0. Now let's think about what that means in terms of my number of roots and the types of roots. So in this case, I'm going to end up with -b plus or minus 0 over whatever. Here's the thing. If I'm adding or subtracting 0, this whole piece goes away. If that whole piece goes away, I'm just left with -b over 2a. If I'm left with that, that's just one fraction. That's one root. So again, if I'm adding or subtracting 0 in my fraction, I'm like not adding or subtracting anything at all, and therefore I just have one fraction. In this particular case, again, my types of roots are going to be real, not imaginary, because there's no -0, so it's not a thing. Let's take a look at this, solve by substitution. The actual set of instructions also said to write the name of the shape by each formula. So this we know is linear, and I don't know if you've covered this or not in the past, but this is a circle formula. This is the formula of a circle. It's not really a function, but it's a function because it doesn't pass circles don't pass the vertical line test. But we are capable of graphing it, so we know what to do. So with substitution, what we're looking at is we're saying, hey, y is here. I'm going to replace y with all of this in this particular example. So I'm going to end up with 40 equals x squared plus x plus 4 squared. So we know that when this is squared, we're kind of like saying I have x plus 4 and another x plus 4. So I'm going to end up with x squared plus 8x plus 16. All of that's going to be added to another x squared, and that's 40. So 40 equals 2x squared plus 8x plus 16. I'm going to divide everything by 2 to make my numbers a little bit simpler. So 20 equals x squared plus 4x plus 8. Subtract 20, I'm going to end up with x squared plus 4x minus 12 equals 0. And then I can go in and factor. So my factors of 12 are 1 and 12, 2 and 6, 3 and 4. So I know that 2 and 6 will work out. So I'm going to have positive 6, negative 2. I'm going to set each of these guys equal to 0. So x is going to be negative 6 and x is going to be positive 2. So for the most part, what happens is most students, the mistakes that most students make is they'll get these x's, excuse me, they'll get these x's and they will leave it at that. However, when we're solving a system of equations, we're looking for points where these two equations meet. And in order for a point to meet, in order for us to have the ability to have a point, we need both x and y. So we are now going to go ahead and take both of these, both, not just one, both, and we are going to place both of these x values into my original equation. So let's go ahead, let's do like a different color, into this original equation. So I'm going to have, the first thing I'm going to have is y equals -6 plus 4 and y equals 2 plus 4. So -6 plus 4 is -2, 2 plus 4 is 6. And then I know right away that this is my x and y value, and this is my other x and y value. So my solutions are -6, -2, and 2, 6. Those are my solutions for this particular system of equations. Now, as I'm moving through this, I know I'm talking a little bit fast. Definitely pause me if you need to, go back, retrace, see if you can attempt this particular problem. You know, it just, things that you would normally do in a tutoring session, I would definitely recommend going for it. Okay, so in this case, we want to substitute again. So I know I have a y here, but I have a negative y here. So instead of leaving this negative y, I'm just going to divide or multiply the whole equation by -1 to give me y equals 2x minus 3. So now I can take this 2x minus 3 and put it in place of that y. So I'm going to end up with x squared minus 6x plus 13 equals 2x minus 3. Bring everything over to one side because I have an x squared and an x, right? And so when I have x squared and x in order to factor, I'm going to bring everything to one side. So I'm going to end up with x squared minus 8x plus 16 equals 0. And now I can go in and factor. So my factors of 16 are 1 and 16, 2 and 8, 4 and 4. That's supposed to be times. And I know that just by looking at these, the only thing that's possible is my 4 and 4. So I'm going to do x minus 4 equals 0. In this particular case, you will only have one solution versus two solutions. Take a look at how I know this. When I solve x minus 4 equals 0, I'm going to end up with x equals 4. When I solve the other x minus 4 equals 0, I'm going to end up with, again, x equals 4, right? So because I only have one x solution, as opposed to in here I have two x solutions, what's going to happen is I'm going to have one solution. So I'm going to take this x equals 4 and plop it into one of my equations. Normally, I would say always do the first, the original equation, like one of these two that's written in black. However, I have seen in the past teachers are totally fine with you putting them into simpler equations. The reason why I mention this is because here I have a negative y, and so I'm going to have to divide by a negative, and you're going to have to remember that. Here you don't have to, you just go y equals 2 times 4 minus 3. So 8 minus 3 is 5. So my only solution is 4, 5. Now, I would recommend in this particular case to go back in and say, hey, this is what the graphs look like. This is where they meet. This is why they only meet in one place. When we look at these two, we have a quadratic equation. And again, we have a linear equation. So in this particular case, we probably have a happy face and a line going down like this. Oh, I guess it's positive slope. So maybe the line goes like this and they kind of meet like right here. That's what that graph is going to look like. In here, because they meet in two places, you have a circle and then they kind of meet in here and in here. All right, let's take a look at this word problem. Let's dissect what it means and then we'll move forward. They did have this kind of piece of information. They are looking just for the width. I've seen that word problems look for width and length, so definitely keep that in mind. Make sure that you're on the same page as what the question is asking. So they're telling us that here's the swimming pool. It's 4 meters wide by 8 meters long. Obviously, this looks like it's 8. This looks like it's 4, so we're going to label it that way. And then it has this uniform width, right? The total area of the pool and the walkway combined, so the total area of this big thing is 64 square meters. So if we are adding an additional walkway around the pool and it is uniform length, this particular portion and this particular portion is going to give me this length right here. I know that these two red pieces are the same, so this will be an X and this will be an X as well. So this entire length here, or width, or whatever it is, that's going to be 2X plus 4. I'm going to have the same thing on this side as well, because take a look here. I'm going to have this piece added here, part of the walkway, and this piece added here, part of the walkway. And since they're telling me that it's a uniform length, this X piece here is the same as this and as the same as that. So all of the additional pieces that we're going to add is just going to be measurement of X, okay? So now when I look at area, because they tell me the area of the pool is 64 meters, I'm going to look at 2X plus 8 and 2X plus 4. And that whole thing is going to give me 64. Now this should look familiar because this is what gives us our initial piece of a quadratic formula. Let's go ahead and let's FOIL this out. Some students prefer the box method. So the box method, that is like a wonky looking box. I have 2X plus 8 here, 2X plus 4 here. This is 4X squared, 16X, 8X, and 32. I know that I can combine these two. So I'm going to end up with 4X squared plus 24X plus 32 equals 64. Again, I can absolutely divide all of these by 4 to make my life much, much easier. X squared plus 6X plus 8 equals 16. Subtract the 16, X squared plus 6X minus 8 equals 0, and then go in and factor. My factors of X are X and X. My factors of 8 are 1 times 8, 2 times 4. Obviously, it's going to be these two. Nope, it is not going to be those two because we want a -8. Unfortunately, this is not one that we can factor because that won't work. So we're going to use the quadratic formula. So my A is 1, my B is 6, and my C is -8. So I have -6 plus or minus 6 squared is 36 minus 4 times 1 times -8. So this will be 36 plus 32, which is 68. The square root of 68. 2 and 34, and then 2 and 17. So I have a pair of 2's. So now I'm at -6 plus or minus 2 root 17 over 2 times 1, or just 2. One thing that I want to mention when we're here, we can take this, this, and this and simplify it. If we don't have all 3 of these that I can simplify, then definitely don't simplify. But in this case, I do, because 2, 2, and 6, 2 goes into them. So this will become 3, 3, and 1. 3, 1, and 1. So I'm going to end up with -3 plus or minus the square root of 17. So that's my X. But when they're looking for the width, we're going to need to use a calculator to figure out whatever the square root of 17 is. Add -3 plus the square root of 17, and then put that X value into this. However, I don't think that this student is allowed a calculator because if I remember correctly, yes, the top of the review sheet says no calculator. So I don't think that they're actually looking for the width. I think they're just looking for the X value, this unknown number here. So it could be this -3 plus root 17. It could be -3 minus root 17. I don't think the negative will exist just because I know what root 17 is 4 point something. So -3 minus 4 is -7. I would expect a student to know that, but also on a test, I can see how they wouldn't. So I would say it's probably just -3 root 17. like plus root 17. I hope that that was helpful with that last piece. I think if I remember correctly, the correct answer is this, but logically speaking, you can't have negative distance. So anyway, I digress. I will see you in the next video where we're going to continue to cover the same worksheet, and we're going to talk a little bit more about inequalities and systems. Bye.